Hi guys, and welcome to this very first session of Knowledge Talk. In this session I'm going to share a design pattern and then how it can help us in building modern reactive apps. So here is the agenda of today's session. We will start with the need of unidirectional data flow, and then we will jump into what is MVI, and then we will see its implementation in Android, and then what further improvements that can be done. A quick introduction about me. I'm Amit Kumar, working as a software developer at Foundation. I'm fond of language architecture and design specification. So why do we need a new pattern? So with every new going pattern, we first need to understand why do we need yet another pattern? What does it solve for us? And how is it different from rest of the patterns? So I hope all of you guys must be aware of some of the existing design patterns like model view controller or model view presenter or model view model, whatever is that. So what's the problem with those architectures? So before discussing the problems, I would like to explain those patterns a little bit to make things more clear. In the first diagram, you will see a model view controller, that is MVC. So in this case, you have a controller which has reference to many view, and then you have a model which also have a soft reference to the view. So controller, in this case, in the case of MVC, the input is given to the controller, and then controller processes the particular input and then pass the updates to the model, and then model updates the view. In second diagram, we have a presenter, and the presenter and a view has a one-to-one dependency. Input is given to the view, and then view updates to the presenter, and then presenter call to the model, and then model updates the presenter, and then presenter decide to update the view. So basically in this MVP case, the presenter decides what to display in the view and how to display in the view. In the third diagram, we have a model view model. So in case of a model view model, the view is observing many view models at a time. It can observe a single view model also, but it can observe multiple view models also. In this case, the input is given to the view, and then this input is passed to the respective view model. View model then calls to the model and then updates itself. So what are the expectations? In an ideal world, we think of app having only one state at a time, and then updating the state only from one output that it's currently been observing. But in real world, it does not happen. As app grows, the complexity increases, and it becomes really hard to maintain a single state from the previously mentioned patterns. Like you can see in this particular diagram, you have multiple inputs and the multiple outputs. The blue arrows are showing the inputs, and the yellow lines are showing the outputs. So for each button, for each click, for each touch, you are sending multiple inputs to your pattern, and then you are receiving multiple outputs like update the favorite button, watch the trailer button clicked, these kind of things. So let me summarize what are the problems. So the first problem is that the multiple outputs that are coming from the presenter view model. So in case of MVP, the presenter decides what to display on the view. So it can send outputs like view.hide display loading whenever the loading is completed, or display some error message whenever there is an error from the upstream. Or in case of view model, you are observing from multiple view models, like observing the favorite button state, or observing the likes for particular tweet in case of a Twitter app. So these kind of things are basically problematic in case of an Android app. And then second problem we have is that business logic has its own state and view has its own. So in case of MVC, we have seen that model is maintaining the view's state. So model has its own state also, and also it is updating the view. So it's modifying the view's state also. So these two are ultimately are having different states. And that's the similar case with the MVP and MVVM also. So as you guys all know that mutable states are bad, and then mutable states leads to ambiguity, so it's nothing to explain here. And then the nightmare of every Android developer, that is process that when configuration changes. So basically configuration changes like rotating the app or the location change, locale changes. So these can be deadly and provide a very bad user experience to your users. We have MVI, and MVI solves it all. So what does MVI offers to us? So MVI is functional, immutable, reactive, and unidirectional. Functional, you can use a functional paradigms in this MVI pattern, and then your state becomes immutable, that is no more ambiguity in the states. And the second most important thing, that is it's reactive. Reactive means you can observe the state and then react to those changes. And then it's most important point, unidirectional. Unidirectional means all your data flows in one direction. But you must be wondering what exactly MVI is. I haven't told a single word about MVI, so let's see. So MVI is basically model view intent. So model view intent is a presentation layer architecture pattern. It's not a design architecture, it's just an architecture pattern. It's coined by Andre Starts. He is the creator of Cycle.js. Cycle.js is a very popular JavaScript framework. MVI is very similar to MVP and MVVM in looks, but it has some very serious superpowers. So let's see the mathematical view of MVI. So MVI is all about functions. So it has three basic functions. The function one is basically an intent to model function. That is, it takes an intent as an input and produces a model. And then we have another function that takes an input as a model and produces an output as view. The third function is view to intent function, which takes a view and from that view it produces intents. As you can see in the diagram in the right side, that we have a function called intent. This function is producing actions that is going to be consumed by the function model, and then this model is producing a new model that is a kind of state, and then this state is going to be consumed by this view function, and then this view function is producing UI events, and that is going to be consumed by the intent function. So that's the whole cycle, and you can see this, all this is going in just one direction. Now let's understand the user interaction of the app. So for example, let's assume that you have a movie app which is currently showing trending movies to the screen, and then your eyes is observing the output from the screen, and then the information that your eyes is observing is coming into your mind. Your brain is analyzing the input and understanding the screen. Then your mind sees a watch trailer button. So as you see this particular button on your screen, your brain sends the signal to your device, that is by touching the watch trailer button. So as soon as you touch the watch trailer button, it is an output from you, and which is an input for the device. So your input goes into the device, and that's how a whole cycle is completed. And if you will notice that you will see the arrow direction of the arrows in just one direction, that is anti-clockwise. So it's a kind of unidirectional flow, like all the data is flowing in one direction. So now here I map the user interaction to the MVI. So basically, as I told earlier, we have three functions: the view function, an intent function, and the model function. So this view function produces intentions, like you are the view and you are producing intentions to watch the movie. And then we have the intent function that is converting those intents into actions. Actions is something that makes meaning to the model. Otherwise, model does not understand your intention. So we convert into actions, and then this model consumes those actions, produces a new model. And then new model is basically new state that is being passed again to the view, and that is being displayed on the screen. So for example, as you clicked on the watch trailer button, the intention of you was to watch the trailer, and then intent is to convert into action. That action can be a play trailer action, and then this action is passed into the model. The model understands this action, and then it starts to play the video. It basically changes the state from the static screen to a video player, and then that is being displayed on your screen. Now here you will see that the previous diagram. So basically the core of the intent function is a map to action function. So basically this function takes the intent and map it to a particular action. And then the core of the model is the process action function. So this function basically consumes the action and produces a new model. And then this particular model is converted into state, and then that state is being passed to the view. So view have a core function that is render state function. Now let's understand all three components of this particular design pattern. So first let's see what the intent is. So intent is basically a function which interprets the user interaction and it results into actions. Actions are the things that make sense to a model. So this particular functions take a stream of user events and then produces a stream of actions. The second we have is the ModelStore. So ModelStore job is to manage the state of the application. It can also communicate with the middlewares to update the model. The ModelStore basically takes the stream of actions and produces the stream of state. The third we have is the view. So view's job is to render the state and produce the UI events or the user actions event, user intentions event. So basically it consumes a stream of states and it outputs a stream of user events. So now let's see its implementation in Android. So first we will draw a basic diagram. That's the diagram we have seen earlier also. The view to intent, intent to model, and model to view. Now let's define some boundaries. So let's draw some boundaries in our diagrams. So now we have two more components in this particular diagram, that is we have mapped to action function and the action object. Also I have replaced this model to the action processor, that is an actor. Actor's job is to consume the action or produce some kind of result. An actor also can talk to the middlewares or the callbacks or with the repository to produce the desired output. So in this case we have a fake data source to which this particular actor will talk and produce the output. Also we now have two more components, that is an effect and reducer. Effect is basically an object which contains the result of from the actor. And then we have a reducer function. Reducer function takes this particular effect and produce a new state. So now we call this as a store, not just a model. So how a system diagram will look. So let's understand this system diagram. In the system diagram we can see that actor function is not only taking the action, it's also taking the old state. So the reason of old state is to understand the context of the action. For example, when you have a list of movies and you click on a particular movie, that is being passed through the state. That means which particular movie is being clicked. And then if you see the reducer function not only takes the effect, that is the result from the actor, and it also takes the old state. So basically reducer function is a kind of state machine which takes an effect and old state and produce a new state. And then this new state is passed into the view and the whole cycle repeats itself. Now it's time to show you some code. So the prerequisites are only Kotlin and RX Java, RX Kotlin. Though they are not required, but you can still, if you have knowledge of Kotlin and RX Java, RX Kotlin, then it would be very beneficial to you. So let's understand the type of components in this diagram. We can see that our intent and state are the subjects. Subjects are basically kind of a channel to which one can subscribe and to which one can push the events also. So basically we have an intent to action function, that is mapped to action function, which takes the intents from the subject and then produce the action, convert it into action, and then this action goes into an actor function. Actor processor or actor is a function. So the actor function produces the effect and this effect is passed into the reducer. Reducer is a function which takes two parameters, that is an effect and an old state, and this reducer outputs into a new state, and then this new state is sent on to the subject of the state. Now it's time to define our components. So these are the three components, three functions which I have created. The first function is intent to action function. So this is the function which takes an intent and produces an action. Then second we have a function that is actor function, which takes an state and action and produces an effect. It basically produces a stream of effects, not just the effect, because one action can produce many effects also, like effect loading effect and then loading completed effect or the error effect. And then we have a reducer function. The reducer function takes the old state and the effect and then produces a new state. That's how I define it into the Kotlin. Kotlin have a nice feature called type alias. So basically you can name your lambda functions, or you can basically define a type to your functions. Then you don't need to create the functions again and again. You can simply declare them as a variable also. Now I have created an abstract view. Abstract view is just an interface. So this have two generic type, that is a view state and the intent. So if you see that we have a function called render that consumes the view state, and then we have a variable which is an observable of intent. So if you are not familiar with RxJava, observable is a kind of a stream that can be observed. So in this case we have an observable of intent. That means the observable of intent means the stream of intents, so in which on which we can push the events. So I have created an abstract store. Abstract store basically manages the state of the application. It is very similar to a model and it bounds to a particular domain. So store basically is a consumer of intent, observable source of state. Consumer again is a feature of RxJava. So it marks this store as a consumer of intent. That means it can consume intents. It can take those intents. And then it's an observable source of state. That means it can emit states. One can subscribe to store and listen to the changes in the states. It has a variable called state that is to just expose the current state of the model. In this particular example, we will create a trending movie app. This movie app just uses the TMDB movie API and then just load the trending movies. If you like to follow the code along with this video, then hold on for a second and visit to the link mentioned in the end of the video. Here I will first define some intents. So what intents can be? So whenever the user opens the app for the first time, you can see initial load intent, and then you can see some refresh intent, like for example in case of a swipe to refresh feature. And then whenever the, let's say example, you have loaded 100 movies on the very first query, and then you scroll to the bottom of the recycler view, and then at the end of the list you load 100 next movies, so that you can give an effect of endless infinite scrolling. So that you can give an effect of infinite scrolling, and you can load more data rather than loading data at once. And then we have a view movie details intent. That is just an intent I have passed, so that whenever a user click on the particular movie, its movie details have been displayed. Now I've created a sealed class that is called actions. Here you can see that we have an object load first page of type action. We have an object of load next page of type action. Then we have a data class. So I have used data class for load movie details because I have to pass a constructor. Object that is a singleton class cannot have constructor in Kotlin by default. Either I should have to create a custom singleton holder. Otherwise, I can simply use a data class. So these are my three actions. Now this is the effect. Effect is, as I mentioned earlier, effect is a result. So this is the effect class. As I have mentioned earlier, it's a kind of a result. So what are the results that can happen for our first trending feature? So it can be the started loading, whenever the loading is started. It can be the loaded response, like whenever we receive the response from the server or from the API. And then the third we have is error loading. So loading can have an error also. For example, if you don't have any network connection, or there is some misconfiguration with your API. And the fourth effect is open movie details. It's just a simple bypass effect that I have added, so that I can open a new activity to view the movie details. And that's how the state class looks. So this state, will be the state of our trending feature store. So in this case, I have a first state I have is loading first page state. So then this is basically the default state of the app. So whenever the app starts, this will be the state of the current trending feature. Then we have a second state, that is error loading first page state. So this state will reflect the error whenever we fail to load the first page. So it basically reflects that we don't have any data. So we can display a blank screen with saying some encountered an error or some kind of stuff. Third, we have a show content state. Show content state basically a data class which have some list of trending movies and a count of page, like how many items I have loaded. So these have been divided into pages, so I can keep a reference to the page. Like if I am on page 1 and at the end of the list I can start to load page 2. So this is basically for that. Then I have a fourth state, that is show content and load next page state. It basically a state like whenever we are loading the next page, so we can show a loading spinner at the bottom of the screen to give a better user experience and let the user understand that we are loading some more data for him. And then fourth, we have a show content and load next page error state. So it happens like initially you have the internet connection and then you load some movies in your screen and then the user scrolls to the bottom, but at this time when the user scrolls to the bottom the internet is not available and we cannot load we cannot load more pages. So what happens here is that you cannot inflate the loading first page state, because that will be shown as because that reflects the state when we don't have any data. But this time we have at least loaded some data previously, so we can keep showing that data and then just show a snack bar or kind of a toast to the user. So now I have created a trending view model store. This view model store extends view model and implements the store interface. Just to mark this as a store, and I have created it as a view model. I created it as a view model because this helps us in managing the state of the application across the configuration changes. Though there are different solutions for managing this, you don't need to use Android or view model. You can do it in different manner also. But here, just to keep things simple, I added a view model. So as you know that we have a store interface, which was a consumer of intent and a subscriber. So as you know, the store interface was a consumer of intent and an observable of state. So in this case, you can see that this particular store has two functions: accept and subscribe. Accept function basically consumes the intent, and subscribe function basically subscribe to this observable source. That is our trending VM store. And then the state variable, which is going to reflect our current state. So in this particular case, I have created intent subject. Subjects are basically like a channel that I have told earlier. One can subscribe to it and one can push event to it also. So it acts like a bridge. So it acts like a two-way bridge. So we have an intent subject and we have a state subject. So publish subject and behavior subject are just two different type of subjects. Behavior subject just keep the last loaded data also, last updated data also, so that we can use it later on whenever the app restart across the configuration changes. And then I have created a disposable. Disposable is just a container of RxJava in which you can add all your disposables so that you can dispose them whenever they are not required. Now let's fill our functions. So the accept function will takes the intent, that is the intent subject dot on next intent. So we are basically accepting the intent and passing it to the intent subject. And then in case of a subscribe function, the state subject is going to be subscribed by the observer. In this case, our observer will be our view. So now I'm going to show you some functions, that is intent to action function. This function basically is of type intent to action function that we have declared earlier. It basically taking an intent and producing an action. So I have basically mapped it. So for every intent, I am producing a kind of action. For example, in case of initial load intent and load refresh intent, I am loading the same first page. But in case of next page intent, I am loading the next page. Next we have an actor processor function. So basically it's an action processor function. This function, as I've told earlier, it takes an state and action, produces an effect. So for example, whenever the action is load first page, I'm just loading the data from the repository, and then whenever it's the next page, I'm just loading the data from the repository with the current page of the state. These are just my implementation. You can implement it anywhere, however you can do it. Just keep in mind that your state and action will be the input and your effect will be the observable of effect. And then this is a reducer function. Reducer function is basically a kind of a state machine which is taking my state and the effect and producing a new state. So this is a kind of if else statement, like when if state is this and do this, and if state is this particular, can do particular this changes and return this state. It all depends to you. Just keep the things in mind. Take an state and effect, applies into it, and then returns a new state. Now it's time to bind all these things together. So in the init block of this, I have subscribed to my intent. So basically I first map the intent to the action, and then I subscribe to it by an invoke actor function. And the result of this subscribe function is a disposable. So I have added the disposable into the composite disposable container. Now I have an invoke actor function. This invoke actor function is just executing the actor function and then mapping the result of actor, that is an effect, into a state value using the reducer function, because the output of reducer is the state. And then in the subscribe function, I am just pushing this result of the reducer function, that is the new state, into the state subject. So whoever is listening to my state subject can get notified about the new states. Now it's time to connect the view to the store. So I have created a trending talk activity, which is basically implementing the trending talk view. And trending talk view, with this I have created a intent subject so that I can push the events to this particular function. So now connect the view to the store. I have a trending talk activity which is implementing the trending talk view. So basically this will be our MVI view. So here I have a disposable like before, and then I have an intent subject. So on this intent subject, I am going to push my input events, user events. And if you see the last two lines, those two are the very interesting lines. So here I have wrapped, here I have subscribed to the intent subject and the view model state subject. So in case in the second last line, that is observable.wrap.subscribe. So what I am doing is my view model was a store, and that was a observable source of state. So I wrapped the observable source into observable just to convert it into an observable, and then I subscribed it by a render function. So it basically reflects the parameter that is being passed into this lambda function. So in this case it is an state, because the view model is an observable of state. So then I am passing this into the render function, that is the current state. So whenever the state is going to be changed, the render function in this particular activity is going to be called. So in the last line, you can see that intents are being subscribed by view model. View model is a consumer, so we can subscribe to an intent subject. So this intent is now being subscribed to the view model. So whenever our UI, our activity push any event to this intent subject, it will be consumed by this our view model. And now, just to prevent memory leaks, I have cleared the disposable in the onDestroy method. So this will help us in preventing memory leaks. And so once we tie these all things together and work, what we achieved. So we have a unidirectional data flow, that is activity to intent, intent to action, action to actor, actor to reducer, and reducer to view. And all this data flow continues in a single direction. And the state is now becoming immutable and predictable. So when you can clearly understand that when I'm on a state 1, I can only go to state 2 and state 3. And when I'm on a state particular X, then I can go on state Y, and I cannot go back into state T. So you can predict your states based on the inputs and the result from the actor. Now also you can see in this particular screen attached that there is no state loss because of the view model. You can use a different manner also to maintain them, to manage the state of the application. And now the app is reactive, so whenever the state changes, it is going to be notified. So like for example, once the internet connection is gone, you are observing the state, and the state can notify our view. And you can also see that our application is now reactive in the sense that it is observing the state and passing the intents at the asynchronously and reacting to the changes whenever it is happening. So till now you have successfully implemented MVI. So that's the whole core idea of MVI. That's not a very concrete implementation, a very uh, perfect and robust implementation, but yeah, that's a good start, and you can understand the unidirectional flow and how things works in MVI. What are the further improvements that can be done? So basically you can create an implementation of store so that it can be reused and you don't need to write all those disposables and invoke functions again. Error handling can be done better. For example, if there is some error coming from upstream, then you can display toast, etc. Post processing for further chaining of actions, it is very required. For example, once the user, in case of a user sign in app, when the user sign in success, you start loading another data, for example kind of a Twitter feed or kind of things. And then the single live events problem, for example a push notification or a broadcast receiver which comes many times in Android apps. You need to handle all those cases also with the state. And the fifth problem is managing overflow of states. Otherwise, as you can see, this can happen to you. Thank you very much, and if you like to see the code, then you can visit to the link shown in the slide.